Here you will learn how to find the minors of a determinant. So there are certain things to be kept in mind. Minors of an element Aij is denoted by capital Mij. This is how you denote the minors. Minor of an element Aij of a determinant is the determinant obtained by deleting its ith row and jth column in which Aij lies. I'll explain you that with an example. For example, we need to find minor of A11, an element that belongs to first row and first column. So if you remove the first row and the first column, we get these four elements. That is, we get a determinant of order 2. We can do the calculation and we know how to find the determinant. Similarly, minor of an element that belongs to second row and second column. We remove the second row and second column and we obtain determinant of order 2, A11, A13, A31, A33. A11, A13, A31, A33, and we can do the calculation. For an example, minor of 4 in this determinant. 4 belongs to second row and first column. If we remove second row and first column, we get 2, 3 and 8 and 9. You can see here the calculation is done. Second row and the first column. And finally, you have to keep this in mind. That is, minor of an element of a determinant of order n. N has to be greater than or equal to 2, because we can find minors of determinant of order greater than or equal to 2 is the determinant of order n minus 1. Just like we have taken an example of determinant of order 3 and we are getting minors as determinant of order 2. This is how to find the minors of determinant of order 2. You have already learned how to find the minors of determinant of order 3. So, minor of first and 1, that is removing the first row and first column, I get 822, which is obtained by deleting first row and first column. Minor of M12, which is obtained by deleting the first row and second column. We get 821. First row and second column. M minor of the element that belongs to second row and first column. Second row, first column, A12. It is A12, which is obtained by deleting second row and first column. Similarly, minor of element belonging to second row and second column is A11. Second row and second column is A11. Here's an example to find the minors of all the elements. For M11, remove the first row, first column, we get 9. M12, first row and second column, we get 8. M21, second row, first column, 6. And finally M22, second row and second column is 5. This is how you find determinant minor of determinant of order 2. So here you will learn how to find the cofactor. So if the minors are multiplied by a proper sign, we get the cofactor. The cofactors of the element Aij is capital Aij. This is how we denote. I is the row to which the element belongs and j is the column to which the element belongs. The formula is -1 to the power I plus j, capital Mij. Example, we'll take an example here. Cofactors of the element that belongs to first row and first column. If you remove the first row and first column, we get the minor. So minus 1 to the power 1 plus 1, m11. Minus 1 to the power even is plus, we get the minor. It's a calculation. To find the cofactor of the element that belongs to second row and third column. Second row and third column. 3 plus 2 is 5 odd, minus 1 to the power odd is negative. This is the cofactor. We'll take an example from the book M.L. Agarwal, exercise 4.1, question number 4 first. The determinant is given and you have to find the cofactor of the element that belongs to first row and second column, which is minus 3, the element minus 3. This is the symbol, the formula. Odd, minus 1 to the power odd is negative sign. The minor of 1, 2, you know how we have learnt. 6 into minus 7, minus 1 into 4. And the final answer is this. This is how we find the cofactor. So you have learnt how to find the minor and the cofactor. So using the concept of cofactors and minors, we are going to solve one question from your book, exercise 4.1, question number 13. Using cofactors of elements of second row, we have to find out the value of the determinant 5, 3, 8, 2, 0, 1 and 1, 2, 3. Remember, they have asked us to use the elements of second row. Elements of second row, they are 2, 0 and 1. I have written here 8, 2, 1 is 2, second row first column, 8, 2, 2 is 0 and 8, 2, 3 is 1. Minor of the element that belongs to second row and first column. Second row and first column is this. I remove the second row and first column, 3, 8, 2, 3. That is the minor. So minor of the element that belongs to second row and first column is 3, 8, 2, 3. So you can calculate 3 is a 9, 9 minus 16, we get minus 7. Similarly, minor of the element that belongs to second row and second column. Second row and second column. Second row and second column is 0. If I remove second row and second column, I have 5, 8, 1, 3. 5, 8, 1, 3. 5, 3 is a 15, 15 minus 8. So these are the minors of second row and second column. Similarly, minor of the element that belongs to second row and third column. Second row and third column is 1. If I remove second row and third column, I have 5, 3, 1, 2. So 5, 3, 1, 2. 5, 3, 2 is a 10. 10 minus 3, we get 7. The formula for cofactors you have already learnt. Minus 1 to the power I plus j into mij. Minus 1 to the power odd is minus. Already calculated m21 as minus 7. Similarly, cofactor of 822 minus 1 to the power 4 plus cofactor of 823 2 plus 3 negative 5 minus 1 to the power odd negative minus 7. And then the formula for finding the determinant using second row elements. This is the formula. Sum of the product of the elements of second row and its cofactor. Element of that belongs to second row and first column and its cofactor. Similarly, 822 and its cofactor, 823 and its cofactor. Add them and then we get 7. So this is how we find the determinant of a matrix by using elements of a particular row or a particular column.